Well, ladies and gentlemen, it is 8:30 in the Netherlands, 3:30 in Japan. Time to start our Netherlands Hydrogen Smart City webinar as part of our virtual hydrogen mission to Japan. Welcome. We organize this webinar from the Netherlands Embassy in Tokyo and the Netherlands Enterprise Agency in The Hague in the Netherlands. First, I want to introduce you our team. On my left is Mariko Nakano-san. And on my right is Nico Dirksen. And I am Rob Stokes, your moderator of today. And if you have any questions on technicalities to follow this webinar, you can shortly mail to the mail account that is written below Nico's picture. And we, as I said, we organize this webinar together with our colleagues in The Hague. And I would like to give shortly the floor to Alexandra de Vogel, who is the Advisor International Technology and Innovation Missions back in The Hague from the Netherlands Enterprise Agency. Alexandra, would I give you the word?
Thank you, Rob. Well, yes, my name is Alexandra de Vogel, and I work for the International Innovation Department at the Netherlands Enterprise Agency. And we organize these innovation and technology missions for Dutch companies, research institutes, and organizations, together with our colleagues at the embassy, like Rob and Nicole. And we facilitate knowledge exchange and opportunities for collaboration for our participants. And this is one of multiple hydrogen missions we've organized together already. I'm looking forward to hearing the opportunities this mission has already brought about and will still bring about in the next few days to come. So good luck, everyone.
Thank you, Alexandra. So today's program, after my short opening, we will have 5 presentations today from Stedin, Panasonic, the city of Hoogeveen, Toshiba Energy Systems, and KIWA. During the presentations, the speakers, the presenters will talk, and if they are not presenting, the presenters will be muted. We will operate the PowerPoint from our side. So presenters, you're kindly asked to say next slide, please, when you go to next slide, and we will operate that. After the 5 presentations, there will be time for Q&A. For all attendees, if you have a question during the presentations, please use the Q&A function and ask any question to the you might have to the presenter. And if you have a question, please indicate the name of the presenter to who you want to ask the question. And we will ask the presenters to react to those questions in the end. And after the Q&A session, we will do a short closing remarks. And I expect that we will resume this session like about 9:50 in the Netherlands, which is 4:50 in Japan. The first opening from my side. So from the embassy, just as Alexandra, the RVO in the Netherlands, our role is to stimulate and promote bilateral relations between the Netherlands and Japan. And we do that in many areas in our innovation team. And today's topic is, of course, hydrogen as part of the energy transition. What we do for this, for example, is organize delegations. Today, this is a virtual one. In the past, we have been organizing quite a few physical. At that time, we just called them delegations. Now we call them physical delegations. Over the past years, and on the right top behind, you can see a picture of a few booklets of participants of those delegations. So that's the first one already in 2016. We've been organizing that for a long time. And many of you have participated in these delegations. And delegations, they lead to collaboration. And there are different types of collaborations, and I just want to mention one of them is collaboration between the governments of Japan and the Netherlands. And maybe some of you already know, but last year in September 25, the Ministry of Economy, Trade and Industry of Japan and the Ministry of Economic Affairs and Climate Policy in the Netherlands signed a memorandum of cooperation on hydrogen. And with this memorandum, both countries recognize each other as playing a leading role in this area and needing innovation and international collaboration to throw forward this area. The memorandum was signed actually during the second hydrogen energy ministerial meeting that was held last year and organized by the Japanese government here in Tokyo. And it was signed by the Japanese side by Mr. Hirohide Hirai, who is, or at least was at the time, the Deputy Commissioner of the Agency for Natural Resources and Energy of the Ministry, of the MITI Ministry. And on the Dutch side, it was signed by Mr. Noah van Hulst, who was at the time our hydrogen envoy, also of the Netherlands Ministry. And maybe some, and I hope actually many of the participants today also listened in the third hydrogen energy ministerial meeting that was held the day before yesterday, and also again organized here in Tokyo by the Japanese government. And I would like to share a few takeaways that are relevant for our bilateral relations. 4 points. One, in the opening, the Executive Director of the International Energy Agency, Mr. Pawiroredjo, he announced 3 good newses, of which one was here that he announced Mr. Noah van Hulst, who was the signer of our MOC that I just mentioned, our Netherlands hydrogen envoy at the time, is not that anymore, but is now was announced by Dr. Pawiroredjo as the new hydrogen advisor of the IEA. So this is a very nice news, I think. The second takeaway was that our Minister of Economic Affairs and Climate Policy in the Netherlands, Mr. Erik Wiebes, he gave a video message of 4 or 5 minutes, but basically saying that the Netherlands is stimulating investments and innovation in hydrogen, and he put the Netherlands on the map as a hydrogen hub and as an important country in the EU in terms of backbone infrastructure. The third nice issue or takeaway is that during the industrial sessions that followed the ministerial session, there were 2 presentations from the Netherlands, one by Shell and one by Stedin, and I welcome 2 colleagues from Stedin here to also join here. Thank you very much. And from the Japanese part, there were industrial presentations from Toshiba and Panasonic, and many more, but these 2 I mentioned, of course, because they are also here with us today. Thank you very much for being here. And so now we're going to start, and I'm really happy that now we can also zoom in a bit more on the bilateral relations, and I hope that the presentations will be informative for all. And I give the first presentation, the floor to Stedin. And the presenter today from Stedin is Mr. Patrice Pawiroredjo, who is Innovation Specialist at Stedin. Mr. Pawiroredjo, I give you the virtual floor.
Thank you, Rob. Good morning, everybody in the Netherlands. Good afternoon, everybody in Japan. Today, I would like to share with you the perspective from a distribution system operator on hydrogen in the energy system. So next slide, please. My name is Patrice Pawiroredjo. I work as an innovation specialist at Stedin. Next slide. So Stedin is a distribution system operator in the western part of the Netherlands, where we service about 2 million customers with electricity and gas. And in our service area, we have the major cities of Rotterdam, Utrecht, and The Hague. Next slide, please. So why are we interested in hydrogen? Next. As you all know, the Netherlands has also signed the Paris Agreement and has translated those goals set in the Paris Agreements to national goals. And if you look at this picture and you see the second target from the left, that shows that in the built environment in the Netherlands, we need to reduce our greenhouse gas emissions by 3.4 megatons in 2030. That is almost 50% reduction. And looking at this picture, it seems like maybe the smallest target, but it's also one of the most difficult to achieve because it's such a diverse area in the built environment. So let's zoom in on that for a quick bit. Next. Next. Could you continue going? So it's well known in the Netherlands that we have very well developed and a very well meshed gas connections in the Netherlands. Almost every building in the Netherlands is connected to the gas distribution grid. So we see that as a substantial asset that we can use on our way to decarbonization. But we also have a very relatively old building stock. So as you can see, almost more than half of the buildings are older than 45 years, and some of them, a significant part, are also older than 75 years. So that presents a significant challenge for us. Next, please. So the problem with these buildings is they're very old, and most of them will still be around in 2050 also. So we need to find a way to transition the heating demand for all those buildings by 2050. So by the end of next year, every municipality in the Netherlands needs to have a plan for an alternative for natural gas to heat the built environment in the area. And from Stedin perspective, we will investigate what are the options that present the lowest societal cost to a society in a specific area. Of course, there are several options. Could you continue? Of course, you can go full electric. You can electrify all the buildings. Next, please. We could go to electricity and a distributed heating system. So district heating system, central district heating system. And you can also go to the next, which is, of course, a sustainable gas making use of the current infrastructure. Next. So at Stedin, we started to analyze all the neighborhoods in our area, and we came to the conclusion that if you look at the purple color in the pie charts to your right, you can see that a sustainable gas solution could be the option at the least societal cost for a significant part of our surface area. So that's something that we really need to investigate further. How are we going to operate that option of sustainable gas in our surface area? Next, please. So for hydrogen and specifically as sustainable gas, what are we doing to develop the capabilities to implement hydrogen in the built environment? Next. So the goal of our innovation program is to develop the capabilities for the distribution of 100% hydrogen using the existing natural gas infrastructure in the Netherlands. And the goal we've set, sort of the point on the horizon for our program, is that in 2025, we want to convert the village of Stedin Haringvliet to 100% hydrogen, from natural gas to 100% hydrogen using the existing gas infrastructure. And it's a village of about 600 houses and also some utility buildings. So that's the program we're going to work on in the next five years to develop the capabilities to convert this village in the Netherlands. Next, please. Next. So some of you are familiar with some of the steps we're putting in the meantime. One of those steps we've started last year is the pilot location for the 100% hydrogen boilers. I think some of you have visited already and are very familiar with this program, where we have 3 hydrogen boilers at the moment being tested by Remea, Bekaert, and Gastera. So that's the first step we said last year. Next, please. Next, could you continue? So the village of the Green, on the campus of the TU Delft, there's an experimental village, the Green Village, and what we're doing there, we are pleased to announce that we are in the startup phase of this project to get hydrogen flowing. We've constructed a natural gas grid as on the way that we would do it normally. And we're going to transport hydrogen using the components of the natural gas grid. So you can see the regular components and the regular materials we would use in the natural gas grid in the Netherlands. The distribution grid are going to be tested for the transport of hydrogen. And it also gives our colleagues, our technicians, a chance to really develop practical skills in in working with hydrogen and develop working operations and safety operations measures to work with hydrogen in the built environment. So this is a very project we're very enthusiastic about, and hope we can get it started by the end of this year. Next, please. And another project that we're starting actually next Monday, I think, is the start of this project, is that we are going to convert 14 abandoned houses in the city of Uithoorn. So these are houses that are going to be demolished, that are not inhabited at the moment. And the part of the gas grid that supplies these houses will be sectioned off. And we're going to do some practical tests to see what kind of steps we need to take to convert an actual gas grid and actual houses to 100% hydrogen. And with that, I would like to share a short animation about the project that will be starting next Monday. Next, please. Next.
From natural gas to hydrogen. This is how the conversion works. As a way of reducing CO2 emissions, the Dutch government is planning to stop the use of natural gas in homes by 2050. This means that the original natural gas pipelines can still be used to heat our homes in a sustainable manner. For example, by using hydrogen gas. For this reason, we will convert a number of unoccupied houses for a short time from natural gas to hydrogen, using the existing natural gas pipes in and around the houses. This allows us to gain experience and find out how long it will take to make a house suitable for hydrogen. During this conversion, the gas network will remain available to the surrounding houses, while the unoccupied houses will be disconnected from the main gas line in the street. We will then extensively test the existing gas network for any leaks. The natural gas central heating boiler in these houses will be replaced by a hydrogen central heating boiler, after which we will transport hydrogen through the pipes to these homes. We will only carry this out during daytime working hours and in close collaboration with experts from the safety region. Extensive research has already been carried out in recent years, and we are collaborating with reputable partners, both in theory and in practice. This is how we can confirm that hydrogen is just as safe as natural gas. We are working together to create an environment filled with new energy. Visit our website for more information. This project is made possible by
So hopefully this project will really give us some practical insights on the conversion of part of our natural gas grid to hydrogen. And as you can see, some of our projects are really actually in the built environment where it's very visible. And I think that's one of the strengths of our project, is to really do things where they are visible and where people can see and experience and build public perception on the safety and the applicability of hydrogen. With that, I would like to thank you for your attention. Yeah, thank you.
Yes, thank you, Mr. Pawiroredjo, for an interesting presentation, and also the good news that you start with a new project next Monday. Due to low internet connection, the movie was maybe not as smooth as we could see here on our own laptop, but I hope you could get the image what was happening there. Thank you so much for this very good contribution. And I would like to continue with our next speaker from Panasonic. From Panasonic. Next slide, please. Our speaker is Mr. Yuji Hamatake, who is Chief of the Smart Energy Systems Business Division of Panasonic Corporation. Mr. Hamatake, the virtual floor is yours.
Yeah, okay. First of all, thank you for giving me this opportunity today. My name is Yuji Hamatake, who is in charge of business development for hydrogen fuel cell. Today, I'd like to present our cooperation to future hydrogen societies. Next, please. So today's agenda is 3 points. First, next, please. Our vision for hydrogen society. Next, please. So this is our environmental vision for 2050 to achieve a better life and a sustainable global environment. And we will work towards more energy creation than energy used, aiming for a society with clean energy and more comfortable lifestyle. So this is our big vision for environmental. Next, please. To achieve such a goal, so we have several products in energy creation, like solar, and also in energy storage, batteries, and energy saving product, and also energy management. Our fuel cell is also one of our key items to realize such visions, and also will be a core business in Panasonic. Next, please. So this slide shows that the future concept or future scenarios for low and zero carbon smart cities, and how Panasonic will contribute to such societies. For instance, by having a green hydrogen from a renewable, our hydrogen fuel cell generates powers from hydrogen to several applications. For instance, a power supply in case of blackout to the hydrogen station as an emergency basis. And the other case is to supply such power from fuel cell for the battery, like for EV, some e-bikes, some e-bicycles. So by having such supply chains, it can be realized CO2-free mobility, so to say. And fuel cell also can generate also heat together with powers. So both heat and powers can be utilized to house and buildings to realize zero carbon emissions. So to realize such emission cities with electrifications, our fuel cell can be utilized efficiently. So this is the hope for future societies. Next, please. So this is just examples. Hydrogen smart city has just started in Japan. We Panasonic installed a total output 120 kilowatt hydrogen fuel cell and total 2.9 megawatt of NFM, so which is a natural gas type fuel cell. So these fuel cells can generate both heat and power to contribute such societies, communities, and also such fuel cell can reduce CO2 reductions. For instance, 6,000 tons from NFM. So this is contribution also CO2 reductions. Next, please. So next, our current fuel cell activities. Please, next, please. So this is showing that the current Japanese market for NFM, natural gas-based fuel cell. So from 2009, the market has been growing, and also in parallel, subsidy is reduced. So as of June this year, total accumulated quantity in the market 360,000 units, and more than half of it Panasonic will produced into the market. So this is one good case which this fuel cell was successfully launched as an example in Japan. Next, please. So with such situation and circumstances, so from 2009, Panasonic has been developing a fuel cell every 2 years to get a more acceptance from the market. So we are doing a development to have a more economical benefit, for instance, higher electric efficiency and longer durabilities, and also to meet market demands to the physical fitness to realize more compact size and weight. So this is current our development for this in Japan. Next, please. And also, we are also doing a business together with our partners as a joint development in Europe, like BDR Samia Group, Lemmerhaus, also Fissmans. Next, please. Then next is Panasonic hydrogen fuel cell. So this slide shows that the left side is our current natural gas type fuel cell, and the right side is our current developing model pure hydrogen fuel cells. So by having a current or long accumulated know-how and technology from NFM, natural gas fuel cell, we are now implementing such long experience and reliability into a pure hydrogen fuel cell. And such pure hydrogen fuel cell can get direct input hydrogen from outside. So that's why fuel processor is not necessary. So in this sense, hydrogen fuel cell has strong features with higher electrical efficiency, which is also lead to economical benefit, and also a good quick startup, so good for resilience. Next, please. This is our future concept. Panasonic will offer flexibility solutions for a wide range of power requests, from 700 watt current hour residential output level to large megawatt level, depending on various installation sites. So base of this is that our current developing hydrogen fuel cell, like 5 kilowatt and 700. And those models also implemented our long experience and reliability technology coming from NFM, natural gas base, for 10 or more 20 years as experience. Next, please. So this is our current developing model, 5 kilowatt and also 700 model. So 5 kilowatt model will be launched next October in Japan, and 700 is going to be planned to launch end of 2022 for European market. Yeah, next, please. We are also doing several field tests for this pure hydrogen fuel cell. So this is one case in Yokohama. So we are setting a 5 kilowatt hydrogen fuel cell to supply electric power into the showroom. So this is almost 2 years field test experience. Next, please. And this is a case of Yamanashi Prefecture, which is close to Mount Fuji areas as a power to gas. And this also, we set a 3 unit over 5 kilowatt, total 15 kilowatt, to generate powers and to use such power for the showrooms. So this is also almost 4 years field testing. Yep. Next, please. So this is the last page of a summary. Panasonic will contribute future hydrogen societies with flexibility solutions to the requested power output from 700 to large megawatt, and also with high reliability of core technology and long experience coming from NF1 natural gas fuel cell, and implement such on the hydrogen fuel cell generators. So I hope we can work together to realize such hydrogen societies in the future together. Yeah. Thank you very much for your attention today.
Thank you very much, Hamatake-san, for updating us on the recent developments and also new projects coming up, I hear, so that's very encouraging. Thank you very much. Thank you, arigatou gozaimashita. So I would like to continue with our next speaker from the city of Hoogeveen.
Hello, my name is Kees Boer. I'm a project manager for the hydrogen district in the city of Hoogeveen. And the project is in line with the Stedin projects and Stedin really good to describe the context of the promising of this project. Next, please. What we do in Hoogeveen, like Stedin, we want to show that it's possible to reuse the existing gas network for hydrogen and replace the central heating natural gas boiler for a hydrogen boiler. Next, please. Well, we've got two phases. First, we will build 100 new built homes and connect them to a hydrogen distribution network. And we do it like any existing district in Holland, and to show that it's technically feasible, safe and affordable and comfortable for the inhabitants. A small project within our project is 16 self-sufficient homes, but I come to that later. Next, please. And the main goal, like Stedin, is to go to the existing districts and to convert them from natural gas to hydrogen using the existing distribution network and replacing the existing boilers by hydrogen boilers. Well, we will need hydrogen boilers, certified hydrogen boilers at the end of 2021. And there is not a certified boiler on the market, so we are now preparing a tender to make sure we have hydrogen boilers certified at the end of 2021. Next, please. Here you can see the location. Unfortunately, I can't point it out, but you see this circle there. There's the newly built district will be coming. Next to it is the existing neighborhood, and you also see underneath the circle a factory of the Dutch oil company, where all the gas which is produced in the region is processed before it goes to the national distribution network, and there will be the storage, but I explain it later. Next, please. Next, please. Well, we start with connecting the new built homes to the distribution network, and beneath will be the storage. Well, I come to it later. And then, next, please. We go slowly into the other neighborhood, and we do it slowly, like the project of Stedin, to learn how long it will take to convert to hydrogen in the street, and how long it will take to convert a single home. Next, please. Next, we go face to face, and next. Next, please. Just click on. Yes, next. We've got 3 phases, and here you can see first we start with starting supply, and then we have a loading station. There will be storage. There will be a pressure reduction station with odorization for safety purposes, and this is similar to the natural gas system, and it will go in the distribution network for the new built homes and in the existing districts. Next, please. In the second phase, when the demand is increasing, we will go to local production with the solar farm. Next, please. And we also will use that to balance the electricity network, because it's lacking of capacity, and so we can use the overproduction of electricity. We can convert it into hydrogen. Next, please. Next. And in the last, next, please. And in the last phase, when the demand is increasing further, we will connect to the main hydrogen pipeline of the Hoogeveen, which they are developing right now. Next, please. What next? What we will do in the houses is we replace the boiler and the gas meter and the house pressure regulator. We do some pressure testing. For safety purposes, we will put in hydrogen sensors. We will replace all other gas appliances, for example, the cooking stove. We will replace it by an electric one, and we have to do some adjustments in the kitchen. Next, please. This is a small project within the bigger project, and it contains 16 self-sufficient houses with a car as power plant, and they have together a micro power plant, and with the solar panels they produce in the summer hydrogen, and in the winter they will convert it with a fuel cell to warmth for heating the house, and electricity to load up the battery. And they even have a small windmill to look after hydrogen production in the winter. They use the car as a power plant. They adapt the car so it can use the own produced hydrogen to convert that in the evening when it's in the garage, to provide the houses with electricity and warmth with the fuel cell in the car. Next, please. Next, please. Well, Stedin already mentioned it, but 90% of the households in the Netherlands have a natural gas boiler. Next, please. So it's really promising to use that fact to go to renewable energy. In our opinion, it will be cheap. It's well-known technology. You can use the existing distribution network. It's known to fitters. It's known to the people, and also hybrid solutions are possible to connect the boiler with the heat pump. Next, please. The other advantages are that there is no carbon monoxide. with burning hydrogen that is much safer than natural gas. The research shows that there is less NOx emission than with a natural gas boiler, and eventually there's no CO2 emissions. Next, please. Well, what we did in the project, we developed the hydrogen boiler. We looked in all legal and organizational things we have to adjust to scale it up in the Netherlands. We looked after how we can increase social support in relation to safety issues and costs. We looked into the spin-off for the industry. We think it's really a good scalable option. And we looked after the social cost and benefit analysis and compared it with other, for example, comparing it full electric or with district heating. Next, please. Next, please. Well, the collaboration with other parties has been really important in this project. We collaborated with 22 partners to develop this project, and it originated in the Hydrogen Open Innovation Platform in the Netherlands. And that's a platform that believes that the hydrogen economy can take over the natural gas economy. Because of the amount of wind energy on the North Sea, and we have to stop the gas winning. And in the north, there is the connection to the national gas network. So that's really promising. And the project we did, it was supported by a research grant from the Enterprise Agency of the Ministry of Economic Affairs. Next, please. These are the parties which participated. Thank you. Next. The collaboration and the network is also important for access to finance. The hydrogen network opens the possibility to get the 472,000 research grant from the Ministry of Economic Affairs. There's also an investment agenda for hydrogen in the Netherlands, and that provided a good basis to get European money, a European grant for the region of 20 million to look after the chain of hydrogen from production to use in industry and built environment. And also Hoogeveen got more than 600,000 for the distribution system and installing hydrogen central heating boilers in Hoogeveen. And we expect co-funding of the provincial grant in December. Next, please. The other one is that we, like Stedin hiring fleet, from Stedin, we asked for funding to for $4.3 million euros to transform the existing neighborhood from gas to hydrogen. And we hope to hear from it, get a positive answer on it next Thursday. Next, please. Also, we cooperate with the central government. We are now trying to close a Green Deal agreement with the Ministry of Economic Affairs to solve all the obstacles we encounter in developing these hydrogen districts. We do it together with Stedin hiring fleet, where Stedin also participates, and through these demonstration projects, we can provide with the central government with important input for the long-term adoption of legislations and regulations in order to prepare for upscaling in the Netherlands. Next, please. And then the implementation. Next, please. We are working together with the ship parties are finalizing the system design. We are approaching missing parties, for example, for the transport and storage of hydrogen in the first phase. And we're working towards an investment decision this October. And we will start the implementation in 2021 after the summer. Next, please. Thank you.
Thank you, Mr. Boer, for updating us on your projects and visions, and also collaborations with other cities and local central governments are very interesting. Thank you very much. Thank you. Before we go on, I want to have one small message. I am looking at questions in our Q&A function. I don't see too many yet, so please, if you have questions, again, also speakers, but also attendees, if you have questions, do not hesitate. And it can be small questions or bigger questions, so don't hesitate. Then we go on with our next speaker from Toshiba Energy Systems. Our speaker is Mr. Hiroyuki Ota, who is the Marketing Executive of Hydrogen Energy Business Division of Toshiba Energy Systems and Solutions Corporation. And Mr. Ota, I give the virtual floor to you.
Thank you, Rob. Can you hear me?
Yes.
Okay. Good morning, ladies and gentlemen. I'm Hiroyuki Ota of Toshiba Energy Systems and Solutions Corporation. First of all, I deeply appreciate that the Netherlands Embassy gave us a good opportunity to connect to Netherlands companies. And today I'd like to explain a short brief of our hydrogen business and an expectation for collaboration with Netherlands companies about the fuel cell business. Next, please. This is our company overview with Toshiba Energy Systems and Solutions. It's a heavy electric company located in Tokyo area and also one of the top heavy electric companies of Japan. Next page, please. And the business of Toshiba Energy Systems and Solutions is comprised of these EPC of the various type of the power plants and the T&D and new energy business, including hydrogen business development. Next page, please. Please let me talk about our hydrogen business footprint and the future developments using this figure. We have a long history of fuel cell business. We started the development since 1960s and delivered many sizes and types of the fuel cells until now. We started from the now hydrogen society in Japan as well is opening up for us. So we are concentrating on hydrogen fuel cells and the distributed hydrogen energy storage system containing the fuel cells and the power to gas system development. Today, the theme I'd like to take up is hydrogen fuel. We already have provided many stationary hydrogen fuel cells, but adding it, we also started the development for the maritime application. Please see right up. For instance, you can see a small fuel cell boat in which our hydrogen fuel cell was installed. And also we started the full-scale maritime fuel cell development in this year. Actually speaking, the fuel cell vessel construction and the operation project, which are subsidized by Japanese government, were embarked on in this year as a collaboration project of Japanese companies, including Toshiba. Our developing maritime fuel cells will be installed in the vessel. We'd like to release our full-scale maritime fuel cells at least in 2023 to the market using those demonstration results. Next page, please. As I said, this year, 5 companies, including Toshiba, acquired a subsidized demonstration project of the hydrogen fuel cell vessel. The companies will construct a fuel cell driving tourist vessel in the scale of 100 passengers and a liquid hydrogen refueling system in 2023 and operate them in 2024 in Tokyo Bay. Toshiba is now designing the maritime fuel cell, and that would be installed into the vessel in 2023. I prepared the abbreviated project introduction material, so please watch that for 3 minutes. Next page, please. Could you, yes. Maybe it would be awkward.
NYK is one of the world's largest shipping companies. Toshiba has been providing technologies and solutions related to hydrogen ever since the company began developing fuel cell systems in the 1960s. Kawasaki Heavy Industries is promoting the use of hydrogen energy in the supply chain with the aim of eliminating CO2 emissions. NLinJapan is an energy company that is also a leader in the construction of hydrogen supply infrastructure. And Class NK develops safety standards for hydrogen use as a third-party verification body. These 5 companies have embarked on this fuel cell ship project, a project that aims to utilize hydrogen to power a fuel cell vessel at sea by bringing together the technical capabilities of these companies. Fuel cell ships are future vessels that will be equipped with hydrogen fuel together with fuel cells to convert it to energy. The marine fuel, oil, and natural gas currently used to power ships emit CO2 and earth. The hydrogen fuel is the ultimate clean energy that produces only water when consumed as fuel cells. Hydrogen fuel not only eliminates CO2 emissions from ships, but also can be used as an emergency power source in the event of a disaster to support recovery efforts in a sea. By promoting the use of hydrogen to power ships, we are helping to realize a hydrogen society. Japan, which is a maritime nation, aims to lead the world in the realization of the hydrogen society. Toshiba is developing technologies to face the global high-power fuel cell competition. Kawasaki will establish an onboard fuel supply system and energy management system. NYK will develop, build, and operate the ship. Class NK will verify the safety of the vessel. And NLinJapan will be in charge of supplying hydrogen fuel to the ship. A fuel cell ship realizes a zero-emission voyage, one that emits zero CO2. Hydrogen will change the sea. The fuel cell ship project begins at the port of Japan and brings us one step closer to cleaner shipping.
Thank you very much. Please change the next page. Well, please let me talk about our maritime fuel cell advantages. In developing the maritime fuel cell, we would apply widely proven our stationary PEM fuel cell technology. The fuel cells, including our PEM technology, were already deployed over 80,000 units in Japan. As based on the stationary fuel cell technology, our maritime fuel cell would enable continuous maximum output operation over the long life. Especially, our fuel cell had the distinction of having 80,000 hours design life. And you can see our excellent lifetime from the figure in comparison among the other fuel cell suppliers. You can also expect high power generation efficiency of 48%. Adding it, if you have the case using hot water, the fuel cell can serve 60 degrees C water simultaneously while power generating. The launching to the market would be 2023. Please change to the next. Next page, please. We are expecting participation to the European business using this maritime fuel cell in collaboration with. I'm sorry. Please change to the next. Yes. Well, we are expecting the participation to the Europe business using this maritime fuel cell in collaboration with EU companies, including, of course, Netherlands companies. Toshiba can provide the fuel cell technologies, products, or parts through the partnerships. This diagram shows the value chain of the fuel cell ships. The fuel cell power module system would be the portion Toshiba can contribute to. Finally, these are examples of the partnership. The last sentence. And we can discuss all items over marketing, sales, and local manufacturing. Adding, we don't persist in maritime application. Of course, it's okay to discuss items concerning trains and stationery. This is a common technology. If you would have some interest, please contact us. Thank you very much.
Thank you so much, Otto-san, for a good update from Toshiba and impressive products and developments and future outlooks, and also your interest in the Netherlands. And we hope to facilitate, and we hope you will be successful in those endeavors as well. Thank you so much. And we go on to our last speaker of today, who is from KIWA. Our presenter for KIWA is Mr. Wolter Veenhoven, who is representative Japan of KIWA. Wolter Veenhoven, I give you the virtual floor.
Thank you, Rob. Can you hear me? Okay, thank you very much. My name is Wolter Veenhoven, Hastex, and we are representing KIWA in Japan. Thanks to Alexandra, Chantal, Eric, Rob, Nicole for giving me the opportunity to present the activities of KIWA in Japan. I will focus on the assessment of safety and reliability related to hydrogen and radio. Next slide, please. I will introduce in the following slides KIWA shortly. Then I give an idea of the smart city. In 2 slides, I focus on new markets and the opportunities these markets offer KIWA related to creating trust, in particular the Internet of Things, which require reliable energy and radio devices. In Japan, as well as in the Netherlands and Korea, we will live with new realities in shaping hydrogen and digital societies. In the last 4 slides, I will explain KIWA's services, assessment of compliance with the requirements for the safe use of hydrogen, and compliance with radio regulations. I will show KIWA's client base and KIWA objectives in Japan. Finally, I show our contact details, and please contact us always when you have questions. Next slide, please. KIWA is a global leader in testing, inspection, and certification, and a knowledge institute. KIWA employs approximately 5,000 staffs in more than 40 countries. KIWA creates trust in products, services, process, systems, and personnel. By assisting companies and societies to demonstrate compliance with the safety regulations in Europe, Japan, and virtually all over the world. Next slide, please. In smart cities, such as cities with connected traffic lights to manage traffic, and with factories and buildings with connected devices to improve the management of scarce resources. Appliances and devices are connected, data is collected and processed in the cloud, and provide information for decisions, and more for decisions to be taken automatically. Next slide, please. In smart cities, the connected devices in buildings, homes, factories, communities form the Internet of Things, or IoT, and can make the systems where they are part of intelligent. Intelligent factories and buildings, smart logistics, smart hydrogen refilling stations, smart mobility, intelligent roads, intelligent fuel cell vehicles, automatic driving, smart parking, smart grid, smart metering, home energy management systems, intelligent thermostats, remote control devices. Too many to mention. Next slide, please. The things are connected to data centers in wireless networks, such as networks in maritime and aerospace environments, and mobile networks, such as 3G, 4G, 5G, and future 6G, GSM, Bluetooth, Wi-Fi, RFID, NFC. The rapid growth of the Internet of Things requires solutions for a reliable zero-carbon energy supply. Photovoltaic and wind, and the applications of power to gas is a solution. Manufacturers in Japan develop new products such as hydrogen refilling stations, electrolyzer, fuel cell, micro-cogenerator, and offer other fuel cell applications. The safe use of hydrogen requires transparent, harmonized regulations and strict compliance with these regulations. In the hydrogen society, the use of hydrogen becomes the new standard. Next slide, please. In the smart city of hydrogen society in 2050, there will be 2 networks, according to the schematics of Osaka Gas. The first is a pipeline in what you can see in the right top corner of this slide. The first is a pipeline with natural gas and an electricity network connecting distributed energy systems for renewable energy. Energy diversification for transportation sectors, energy security, and energy management. The electricity line is connected to the second grid in the middle. This consists of the electricity line and a pipeline for the transport and distribution of hydrogen, mainly hydrogen produced in overseas locations, and distributed to communities in the smart city, to the neighborhoods with dwellings equipped with the 100% hydrogen fuel cells, micro CHP, to smart hydrogen refilling stations with microgrids, commercial communities consisting of factories and commercial buildings. The rapid transition to the hydrogen society requires from the manufacturer to make sure that his products for hydrogen production, transport, distribution, and usage are safe and comply with the strict requirements before placing them on the market. Next slide, please. KIWA, as a testing, inspection, and certification body, is specialized in assisting manufacturers to demonstrate compliance with these safety regulations. KIWA is a third party or a notified body for the European regulations and directives. It has laboratories with ISO IEC 17025 accreditations, has Europe's largest hydrogen laboratory for testing with real hydrogen under high pressure and high flow conditions. It tests according to the technical standards of Europe, EN standards, the global ISO IEC standards R134, GTR13, IGV, and HPRD. KIWA issues test reports and certificates for materials, infrastructure components, hydrogen cylinders, electrolyzer, fuel cell vehicles, micro CHPs, photovoltaic, also safety electronics, and what becoming more and more important, also the safety integrity level of software, SIL. KIWA cooperates with authorities in Japan, among others with KHK and JIA, and in Germany with the KBA, and with the authorities in the United States and in Canada. KIWA, as a knowledge institute, assists private and public organizations by offering feasibility studies, redesigning of appliances, and demonstration projects. Next slide, please. Simultaneously, we are in the transition to the digital society. In Japan, the importance of this transition can be witnessed in the redesigning of the government, with the establishment of a special ministry for digitalization. Japanese manufacturers continuously develop novel technologies to make the wireless data communication faster and more efficient. The Internet of Things expands rapidly. Reliable wireless technologies, referred to as the radio, are required to not causing harmful waves, not to disturb the working of other things. In a digital society, the safety and reliability of the wireless devices needs therefore very strict compliance with the regulations. And it is understandable. The manufacturer of these devices demonstrates that his products are in compliance with these regulations, and maybe harmonized regulations, before selling his products on the market. Next slide, please. KIWA is also specialized in assisting manufacturers to demonstrate compliance with the safety regulations as a third party for testing, inspection, and certification of wireless communication devices. KIWA has extensive testing facilities in the Netherlands, among others with a test facility from 9 kHz to 120 GHz. Besides, KIWA is outsourcing tests to laboratories which meet the highest requirements from KIWA. KIWA is designated for approvals based on certification schemes applicable in Japan and in Europe and worldwide. In Europe for the Radio Equipment Directive and the Maritime Equipment Directive. And in Japan by the Ministry of Internal Affairs and Communication for the Radio Law and Telecommunications Business Law. and in America by FCC, and in Canada by ISAT. KIWA's subsidiary, Telefication, was the first foreign certification accredited body who was accredited by the authorities in Japan, and who has still the #1 market share among the foreign conformity assessment bodies in Japan. KIWA cooperates on the national level in Japan. Next slide, please. KIWA's services a client base in Japan among the heavy industries, utilities, appliance manufacturers, electronics industries, manufacturers of car and components, module manufacturers, and laboratories. Next slide, please. The objectives for KIWA in Japan is to be designated as a conformity assessment body, or KIWA's reports and certificates are accepted by the quality authorities where needed. And the objective is that suppliers of hydrogen technologies, electrolyzers, fuel cell vehicles, fuel cell microgenerator, hydrogen cylinders and components, and radio devices recognize and use KIWA as their third party to prove the safety and the reliability of their products. Finally, our objective is that we start new, but also continue our existing cooperation and bridge the gaps between countries and between product development and commercialization. Further succeed in creating the hydrogen and digital societies with safe, reliable energy supply and reliable wireless devices. Next slide, please. Thank you very much for your attention.
Yes, thank you, Wolter, for a very nice and comprehensive overview of the business of KIWA. This concludes our presentations, and I want to first of all, thank very much all the 5 presenters to share with us your slides and know-how and experience. We go on to the Q&A session. I am looking at the Q&A functionality, and we have a few questions. And please allow me to. We have a bit of a mix of questions and also our own questions. So we will ask 1 or maybe 2 questions to each presenter, and maybe we start from the first presenter, if you allow me. Mr. Pawiroredjo from Stedin, could you elaborate a bit? As you know, as part of the energy and climate policies, the Netherlands Task Force TIKI last May recommended to realize a national backbone infrastructure that integrates heat, electricity, CO2, and hydrogen by the year 2030. And we were wondering how this is beneficial or challenging for Stedin as a grid operator. Could you maybe react on that, if possible, if this is a relevant question for you? Thank you.
Yes, thank you for the question, Rob. TIKI is actually, we are expecting the creation of the Dutch Ministry of Economic Affairs on the TIKI report today, which will show us a little bit more the steps the Dutch government will take in implementing the advice of the TIKI report. But the TIKI report is really focusing on the necessary infrastructure, the infrastructure that's needed for the transformation of the industrial clusters in the Netherlands. And for us, as the built environment, it's very important. Our area is surrounds the largest industrial cluster of the Netherlands in the Port of Rotterdam area. So the changes in the industrial settings will definitely affect the heat transition in the built environment. So the development of main infrastructure for residual heat from industry towards the cities, but also hydrogen production in the industrial clusters, if that becomes available to use outside the industrial cluster, this would definitely maybe speed up the developments of district heating networks, but also of hydrogen networks in the built environment. So the interaction between the industrial developments and the national backbone infrastructure will definitely speed up, I think, certain developments in the built environment for us. So it's something we're very aware of, and we're very in contact with both the challenges of an industry and the challenges in the built environment. Yeah.
Thank you. And maybe a small question for myself. I was just interested. You talked about the project in TU Delft, the University of Delft, the green. What is it called?
Green Village, yes.
Green Village, exactly. And I was just wondering, are you only using the facilities, or are you also collaborating together on joint R&D with them?
Yeah, very good question, Rob. So the project is being developed by the three largest distribution system operators in the Netherlands. So Stedin, Nexus, and Alliander are working on that project together. The Green Village is actually a part of the campus specifically geared towards collaboration and on innovation. So we see the hydrogen infrastructure, or the natural gas infrastructure that we're going to use for hydrogen transport. We see that as a platform to collaborate with different technology providers, whether it be fuel cells, whether it be metering, whether it be sensors, whether it be all kinds of different applications that we can test and use and implement on that platform. So yeah, it's definitely meant to attract collaboration with technology suppliers and other parties that are interested in working with hydrogen in the built environment.
Thank you so much. Very good and informative. Thank you. I go on to, I look at the screen of the Q&A session. Mr. Hamatake from Panasonic, I wonder, you as a Japanese market leader in the area of the low carbon smart cities and stationary fuel cells, so how important in your view is the role of the government, and what public-private partnerships do you deem necessary in this respect? And maybe if you could elaborate a little bit on how you see the European market, and of course, especially the Netherlands in this field. If you could say something about that, that would be much appreciated.
Yeah, thank you for your question, Rolf. Yeah, as I explained in my presentations, so for the first Japanese market, so we started also the government support to develop a residential fuel cell market. And also to our areas is that the utilization of gas. Also next is hydrogen. So as a personal opinions, of course, in case we launch this hydrogen fuel cell also to the European market, of course we need also collaborations with the government, also that local partners to establish a total supply chain. So otherwise, also we cannot, utilize these systems efficiently, because we are just utilizing hydrogen to generate power and heat, and also we need really partners to work with.
Thank you. Very good. Next, I have a question for Mr. Boer from the city of Hoogeveen. As we know, the city of Hoogeveen is right in the area where the transition of natural gas in the Netherlands is taking place, which is the northeastern part. And the question is, how important for you as municipality is this position in making visible steps and projects that you are doing right now? I mean, how important is this location for you as a city?
Well, it's quite important because, as I mentioned in my presentation, it gives you access to partners and to funding, and we are really motivated to do something for our city, which is also important for the energy transition in Holland. So we are a small city, but it's really important to be part of the network and be part of the network of all the projects in Northern Netherlands, to connect with partners and to get access to partnerships and access to funding. So that's really important for us.
Thank you so much. I also have for Toshiba, you explained your expectations, but we were wondering also, so the opportunities maybe for European and especially the Netherlands market that you see for Toshiba, also could you elaborate a little bit further on the opportunities that you see in the European market, and also how the government and those public-private partnerships could assist you in this respect? Thank you.
Yes, I was very surprised that this year, European Committee issued the very terrific hydrogen strategy roadmaps. That is very good strategy, and so maybe the promising huge market would occur in the EU, centering on their hydrogen. So we think we need to participate in the European hydrogen-related market. Of course, we need a collaboration, and not only with the European companies, including, of course, Netherlands company, and also government, and yeah. So I'm very expecting that collaboration and to enter into the market. That is a very promising market.
Thank you, Olga-san. And our final presenter, Mr. Veenhoven. This is a personal question also for me, but I was interested. You have been in Japan a very long time, and me too, so we know each other a long time. And I was wondering, due to the thanks to the recent trends in hydrogen, it's really lifting off the past 2-3 years. How does that really impact your business and the opportunities for the Netherlands companies in Japan, like KIWA, for example? Do you see a real rise in business in this respect for KIWA? Could you say something about that?
Yeah, let's say becoming more popular, the hydrogen becoming more popular is of course became also a very important part of the work for KIWA, as well in appliances, and especially also for the automotive sector. So, and yeah, that is for, let's say, there are so many opportunities I see for companies like KIWA also, but fortunately we have quite a good market share, and I of course see also opportunities for other industries, especially component makers from Netherlands who want to sell their products. I think that we started also very early in the Netherlands with developing applications for hydrogen, and so there, and that you can also see at the attendance to this submission. And so there are many companies who have an interest to enter the Japanese market, and I think they have good products to do that. On the other hand, like Mr. Boer of Hoogeveen is asking, he's looking for, let's say, suppliers for hydrogen technologies. I think that also Japan has something to offer for him there. And so I think we can, as Japan and the Netherlands, we can really cooperate with each other towards establishing this hydrogen society. And we have seen so many applications now, also in the presentations of Panasonic and Toshiba, that it's related to the built environment, but it's also related to other sectors, like the maritime sector. So it's very fascinating, and I expect that we have many opportunities in the future, also for the collaboration between Japan and Netherlands.
Yeah, thanks, Wolter. I also see there is also there was a question also in I go back to Mr. Boer from the city of Hoogeveen. There's a question from the audience from Toshiba, actually, from Toshiba colleagues. What is the reaction of the residents near the test area? Because if we do the same project in Japan, one of the concerns is if there is yes or no resistance from local citizens or residents. Mr. Boer, could you give your experience in this?
Well, there will always reactions, but we emphasize that what we do is as safe as natural gas. And because hydrogen is still more expensive than natural gas, we will have to look after that it's affordable for the people. But there's also what I call a buzz. People are willing to cooperate to do something for the environment. So it's really important to invest in social acceptance and also accept that, well, like ourselves, not everybody is into new steps for energy, but at the end, if we can look after a safe energy system which is affordable, I'm sure that that's the main interest of the residents. Well, in Holland it's a specific problem because we don't have a force to say to the people you have to use another energy system, and that's quite a problem because we have a really good collective system, our gas system, that's really reliable, it's really cheap, and so we have to look after the problem to force the people to cooperate, and I mean force. You also have always have to do it with good conditions. But I'm not sure how Japan is organizing their energy system. But if Toshiba wants to know more about what we did to get the social acceptance, then I'm willing to provide some more information.
Thank you, Mr. Boer. And for this question, and as you say, willing to discuss further, and this is more in general. Next week, Tuesday, we will have a virtual session where different organizations have their own virtual table, and this gives possibility to further discuss bilaterally. So if you have further questions, you can also ask them in that sense, and we also help as the embassy to connect to each other. So this closes the Q&A session, and I would like to continue to the closing remarks. And Q&A? Oh, sorry. I got instructions to quickly go to Alexandra in this Q&A session. Alexandra, go ahead.
Thank you very much, Rob. Well, you actually just mentioned that on Tuesday we will organize some networking tables for the Japanese and Dutch participants to discuss further. They're actually informal breakout tables, so you can have small discussions about specific topics with 6 people. So if you have heard something today or in the past days about something which you like to discuss further, you can request a table with either Rob or Nicole or me, and we will set up your thematic table. So actually we will make the final layout of the tables on Monday. So I'd just like to say, if you like to make a reservation, which is, I think, a really good opportunity to be in touch with in a smaller group and really have discussions about maybe about cooperation or knowledge exchange, be quick and make a reservation with us.
Thank you, Alexandra. I think now I'm allowed to go to the closing section. Yes, I look around. I'm happy. It's okay now. So, but before I thank the speakers, I just a few takeaways that I wrote down for myself. I mean, of course, all the issues that we do and the smart cities, the urban environment, there are a lot of opportunities to get to a substantial and sustainable role of hydrogen in the energy transition and having good impact on environment, resources, and in this sense, a very important topic, I think. There are many points that have been discussed, and I just name a few. We have to talk about safety, and that relates again to government relations and statistics and to certification matters. And there are quite a few, the next point, quite a few, which I sometimes even call dilemmas, because you have, on the one hand, long-term goals and short-term actions and how those relate to each other. There is some, you have to hop to the solutions, which is not always a logical follow-up. There are differences in, if you take the individual houses to larger uses of hydrogen, and for example in buildings, but also we heard examples in the maritime sector. There is this chicken and egg between supply and use, and here we are more talking about use. But this is how to connect that to the supply chain that we have been talking about in the infrastructure sense as well. How do local governments relate to national governments? And we heard in the Netherlands a nice, there is this collaboration or maybe even a coalition of cities that communicate with national governments. How do public-private organizations work together? Have to work together. How do new buildings and old buildings, how does that work? And so these are all issues that will be addressed, I'm sure, in the next time to make this a larger step. The third point I want to mention is that promotion and social acceptance is very important. And also to not only the acceptance, but also the collaboration by residents. And as we just heard in the last Q&A also, my feeling is it has to be an easy step-in for people, but not a compulsory. So there are safety issues, and so there are a few issues there as well, or issues, I would say, topics to discuss. And to discuss these issues, collaboration is important, and collaboration, in our sense, today's topic is how bilateral collaboration between now the Netherlands and Japan and all the parties that we have been talking to. And today we have had only organizations, private organizations to discuss. And we, of course, collaboration between companies, sorry, I'm mistaken, Mr. Boer is of course not a company, but we had if we want to have bilateral collaborations between companies, that's one. But we also heard that this bilateral collaboration can only be fruitful if this is set in a bigger environment. So the combination between this bilateral and its environment, so broadening the perspective, having a talk with all the people that are dealing with this project is essential in making those collaborations fruitful. So I think there is a role of government and in our case the embassy, and also that's why we do these delegations, to find each other, but also address the environment for such bilateral collaborations. Having said that, I think we had a lot of discussions, and as Alexandra already said, next week there are more opportunities to talk with each other. But do not hesitate to call us with any further question. And before I give some final remarks I would like to mention also that the Netherlands government, together with a group of companies, has started a public-private initiative, a program, is now preparing that with Dutch companies. And this is a 3-year program, specifically with the purpose to develop relations with Japan. And this is not only for the smart cities area, but this is for the total area of hydrogen. So we are preparing that now. We are in the final phase of that, and from next year, and probably if we can come physically, but otherwise for the time being continue with virtual encounters, and of course things the events like the FC Expo in Tokyo, the Olympics next year, and the hydrogen energy ministerial meeting that will take place every year. Those are events and occasions to organize these kind of delegations within such a program. So there is a lot of energy in the Netherlands to develop the relation with Japan, and we hope that Japanese colleagues can collaborate with us in that sense as well, and get to know each other and make next steps like we did today. And with having said that, my final remark is that this whole session we have recorded, and we will share that with participants. Be assured that the attendees, the people that listened in, they will not be in the picture, but only the speakers, and the slides and the sound that you heard will be recorded, or has been recorded, and we will share that with you, so you can listen back and also share that further with your colleagues. Having said that, I want to thank everybody, especially the speakers, and of course also the audience to listen in, and I hope we have contributed to the dialogue and have made the next steps. I thank again all the presenters. Thank you very much. Arigatou gozaimashita. So with this we close our session. Thank you.